let's get the, okay, are we streaming? Hey, we're streaming.
Anybody here yet?
I gotta figure out, I still haven't figured out like how to grab the link for the live stream without like actually going to
Go
going to like my
You-
page, my channel.
How do I find your page? What's your name?
Okay, I think I know now. It's what is it? It's math programming, I think.
Lane.
Yeah, it should be
That's funny.
compilers, right?
I can hear us.
Good.
Yeah, there's a delay.
Okay.
Yeah.
All right. Welcome back to Compilers and Coffee.
Good to be back, Jeremy.
Yeah, have we ever introduced ourselves? Whatever. No one's watching. I'm Jeremy.
Yeah,
That's
exactly.
Maxim. Okay, so
if anybody ever shows up, if anybody ever shows up, we can do
it. Yeah, I have the chat open, so I should be able to see if anyone says anything. Hi. Okay, so yeah, what's going on in compiler world? So we could work on the Python binding some more. We actually pushed that fix last time. But so I had something else that I was thinking about. So I have like, and I wonder if I can find the IR first, but I had some IR that was basically like scheduling heterogeneous operations that can run in parallel. So it's not like it's like a parallel for construct, right? Where I have like, I think I'm sure I can find examples in here. Yeah, so let's.
What is CGGI?
Yeah, that's the crypto thing that I work on. It's like the crypto scheme that lets you do homomorphic encryption. But so, okay, so you'll see these ops that are like CGGI LUT3. This is like literally a lookup table op.
Sure.
And each lookup table has like maybe a different value. And then they have different arguments. But then, and like, so basically I have code already. Like basically we have all this like circuit, basically, this directed acyclic graph of operations. And we have code that will basically like analyze that graph and then sort them into like levels where like each level is all the ops that can be done in parallel. And then we used to have code gen that could like before we were using MLIR, right? We had code gen that would take those ops and like emit code that would basically in parallel process all of the operations in a level and then wait until it goes to the next level and continue.
Sure.
And I mean, now that I'm thinking about it, that's not like the best way to do it. The best way to do it would be to have like a some kind of like queue, right? Like a queue that says like, okay, just like find the next op to run who's all of the operands that are input to that op are ready, and then just like run that.
If you're really doing this scheduling, if you're comfortable doing the scheduling at runtime, then yeah, I agree with you. But if
right, that would be at
runtime. If you're trying to statically schedule, then
also part of the problem is that in this case we're like emitting Rust code, and so we're emitting Rust code that like doesn't then it's recompiled through the Rust compiler because we're emitting code against some crypto API. At this point, we're not implementing it ourselves in the compiler. So rather than like schedule the individual ops, we're basically saying like, okay, like tell Rust to run these in parallel and then let whatever Rust parallelization thing handle them. And the problem is that when we get down to like the level right before the API, right? Actually, I think I have some end-to-end programs. Let's see. Is this one of them? No. No, that's just the harness. I wonder if I can. Should have. Yeah. Okay. So like, So yeah, these tests are all too small. I want to like run like a bigger one. Um, because basically, so like this is what the exit dialect looks like, right? It's like this Rust
Mhm.
API and then the name of the function, and then it generates code that looks like Rust, and basically you'll see like hundreds or thousands of these apply lookup table ops, just like in a blob,
Mhm.
and I want to be able to schedule them. But then like now what we have is we have basically like a memref of instances of these types. And then we have each of these things basically loading from the memref, doing the lookup table, and then storing back into a different memref. Like it's like compiling some like much longer program that's like shuffling around different memrefs of
Sorry,
different sizes and stuff.
what's in the memref?
So
Inside
each
of
the
the
memref
memref?
is like maybe like a three-dimensional array of like ciphertexts, right? So this is like
Hmm.
ciphertext type. Um,
Hmm.
and so it'll basically say, okay, like it'll have like a for loop, right? And then inside the for loop there'll be a body that says, get the ciphertext at this index, update it, and store it to this other memref at this other index. Um, and we want to be able to like parallelize all of this stuff. But the problem is that in Rust, you can't like have like a parallel loop write to different memory locations in the same memref, without the compiler being able to
Yeah,
like prove that they're disjoint. Um,
yeah.
but like even just more generally speaking, like say we have like a bunch of like memref load ops followed by ops that do the computation and then ops that store back into some different memref, and we want to like
Mhm.
parallelize across all of those. Um,
Mhm.
uh, yeah, what am I saying? I'm saying uh, like what sort of facilities, like I feel like I want some kind of like IR construct that allows me to like take the ops and like write down in the IR the what am I
The
saying?
lifetime?
Like
The
maybe
lifetime?
it's not the lifetime so much as like the independence structure of it. Um,
Well, yeah. So those are. So I was in. Yeah. I think those are in the same ballpark. Like, if I give you the lifetime, you can go from one to the other. If I give you the lifetime, well, if I have all the lifetimes, I can see which ones are independent. If I literally tell you which ones they're independent of, I can impose some lifetime bounds, whatever, something, or at least relative to each other. Um, but you said something that I think is true. I understand the Rust compiler will prevent you from getting a mutable borrow of a of an array or whatever. You're saying memref, but you're talking about the Rust
right,
primitive,
you'll get you
some Rust
in
mem.
Rust it's an array, right? And if you're
Yeah,
doing like a mutable borrow and you're trying to loop over it, and like write
yeah.
and like do a parallel loop over it, right? And have different threads write to it. Even if you know that those different threads are writing to different locations, the Rust compiler is not happy about it. Um, and uh, one of the things we're thinking, okay, like we have kind of a way to work around that, but then the more general thing is like, say you're not in a loop and you just have like a bunch of ops, right? And you just want to like
Mhm.
have some construction that says like these ops can run in parallel, but they are like it's not like a parallel for where it's the same op just on different data. It's like a bunch of
Sure,
different
sure, sure.
ops on different data. And I want to be able
Yeah.
to like have some IR construction that says these things can run in
This is
parallel.
this is very near and dear to my heart. But before I get to why it's near and dear to my heart, a little bit of clarification. If you had this metadata, how would you inform the Rust compiler about this? How are you going to use this to tell the Rust compiler, well, you're wrong?
Well, so one thing I was thinking about doing was like extracting the all of the like store and load indices and like putting those as some kind of like global data associated with the op, and then have it like compute the op value in like all of the op values in one step, and then like batch the all of the stores into like another step.
Oh, so you're
Um,
you're going to cooperate. You're going to cooperate with the Rust compiler. So
exactly,
you're
yeah.
going to change your
I mean,
style. But what about
we
what
could
about
do
just
something
using?
unsafe, but
Yeah. What about just doing unsafe?
well, I haven't tried that yet. But like this brought up the question of like what are MLIRs like constructions that allow you to express like heterogeneous scheduling of operations like that. That's what I feel like is relevant to. to this stream.
So, okay, let's take a look at the dialects because there are some dialects that ring a bell for this kind of thing. There's like async. Well, yeah, I mean, there's those async, but async doesn't have any passes. I think that the runtime, that's not my screen. That's funny. The async runtime ultimately is the thing. Like the coroutine runtime in LLVM is the one that will. Maybe I'm talking shit, but I feel like the independence isn't actually computed in MLIR. Because it's async. It's not statically. It's like there are tokens, and once the token is ready, then the next task is ready to run. But async isn't trying to figure out ahead of time a static schedule. Async is just, and I might be wrong about this, but so take this with a grain of salt. But so there's the async dialect, which tells you about scheduling stuff, right? And there are async regions. There's Is there? There's. I think that the async execute is a region op. If you jump to async execute, yeah. So you can stuff things in there. It's like whatever. Yeah. There's your compute, right? Like arbitrary compute, and it returns a token or something like that, and you pass a token to. So right. So the results. There's a token result, and then there's an actual result, and the token you await, just like await, async await, and everywhere else. But there's no analysis. So if I generally understand these things, which I might not, there's no independence, mutual exclusion thing analysis done. That's the runtime doing those things. They're going to be like, well, we have a task and we're going to run, and there's a poll, there's an e-poll or whatever.
Right. Okay. So this is a way for you to express like I would like to do sort of dynamic runtime scheduling, like async await stuff.
Yeah. Yeah, and please runtime take care of that, man, for me. I'm not going to try to schedule it. The other thing that comes to mind is mesh, the mesh dialect, but that thing has I think nothing in it so far. And the OpenMP dialect. Yeah, so mesh is for distributing across heterogeneous compute. It's like a mesh of compute.
Sure.
It's like the topology of it rather than the.
Yeah, I know that.
Yeah, exactly. Yeah.
And then OpenMP.
Yeah, and OpenMP, but also it's the same thing I believe about OpenMP, where it's the OpenMP runtime that actually handles these things for you, rather than the IR statically scheduling anything. Okay, so that's upstream. Go on. You were going to say something.
No.
Okay. So the reason this is near and dear to my heart is because this is my first brush with compilers, MLIR, etc. In circuit, so the thing that you're talking about is just bang on even the LUT nomenclature stuff for, so heterogeneous compute, whatever. Let's say I have an add and a mul on a fabric of compute, right? Let's say I have 10,000 of them, or I have 5,000 of them. I have 5,000 adders and 5,000 multipliers, and you do, right? Because you do have this like dovetailing into FPGA stuff, right? So like the naming schemes and the circuit model of compute, all the things are very high affinity. That is a real problem in FPGA land. You have, I have my FPGA and I've configured it to synthesize. I've synthesized 2,000 adders and 2,000 multipliers. And those 2,000 adders and 2,000 multipliers are multiplexed to carry out all of the adds and multiplies in a CNN, right? So I multiplex those things in time. Hey, I do a layer, or maybe I do half a layer or whatever, and then I save the results, and then I come back again and compute the rest of the results. Or maybe it's literally a layer at a time, right? I have a DAG of adds and muls, and I want to know what's the maximum parallelism that I can get on my FPGA, which has 2,000 adders and 2,000 multipliers. That is the static scheduling problem in FPGA land. That is everything. That is the entire thing of FPGA land. And so circuit, which speaks to stuff about RTL and FPGA and ASIC, whatever, has tools for this. There's a guy, Julian Opperman, who has a scheduling dialect. And I have a pass that I contributed for this, like it's called. So there are a couple of names here. There's like modulo scheduling, which stands for roughly time multiplexing, because it's like, oh, 3 mod 2, 5 mod 2, 7 mod 2, those all go to the same adder, like on that time step or something like that is where the modulo comes in. So there's a modulo scheduler in there. There's also a scheduler that I contribute that reuses, they're called IPs or whatever, like adders and stuff like this. So resource aware scheduling. Yeah, resource aware scheduling. And that thing lets you just write your DAG write your IR and say, hey, Mr. Julian from his scheduler, tell me the schedule that. So that's not it. That's pipelining. That's this other guy's thing. You're looking for. How did you get there? Code
This is just search
documentation,
dialects.
dialects. So static scheduling infrastructure in the right-hand box. It's not a dialect. Sorry, I shouldn't have said that it's a dialect. It's not a dialect. He was talking about turning it into a dialect, but it's not a dialect.
Ah, okay.
Yeah, so if you jump all the way down to the bottom, available problem definitions. What a problem definition is an ILP. So this is your language, right? A cyclic problem is a particular formulation. It's an ILP and formulation, and then your program is an instance. Shared operators problem is what I added. Modulo scheduling, that's their chaining. I don't remember off the top of my head. And there are a couple of, and then you look right below, there's a couple of ways. So you formulate the problem, and then like there's a couple of ways to solve it. ASAP is what you're doing. ASAP is a topo sort and just schedule everything as soon as possible. ASAP stands for as soon as possible.
Mm-hmm.
So you have topo sorted your operations. That's what you were kind of describing, layers of mutually independent ops, right?
Mm-hmm.
Groups of mutually independent ops. So you have a topo sort that gives you those independent phases or layers or waves fronts, right?
Mm-hmm.
So once you have those mutually exclusive waves, you're just like, schedule the first one, do all of them, then schedule the second one. That's ASAP, as soon as possible. And that's the simplest. That's like, it's another word for that is work list scheduling.
Yep.
Then he's like, oh, linear programming scheduling, and then integer linear programming scheduling. The LP is so simplex relaxation, and then ILP they use OR tools. So OR tools is a dep here if you want to use this stuff.
Oh, I have that already in my project. We haven't used it for anything, but I've set it up because I'm well familiar with it.
Yeah, so the way that this works is, kind of remember, you annotate the IR with an attribute. No, sorry. It annotates the IR with an attribute. It says you run these passes, and you can run this on circuit dialects, but you can also run these on, like, I got it to run on an unregistered dialect. I gave it fake dialect ops and names and stuff like that, and because I just wanted the start and stop times. And so you run one of these, and it'll solve the ILP, and it'll annotate all your ops with the start time and the stop time. The stop time is extraneous, superfluous, but the start time. And that is germane to FPGAs and ASICs, because you have, well, I got 2,000 adders and 2,000 multipliers, and I can actually run, if I pull off the magic trick of scheduling correctly and routing too, I can run 2,000 at the same time. You don't have that. This is the kind of like where I wonder if you should just do async and forget about.
I would have to look. Yeah, that's a good one. I could look into seeing, like, I'm sure Rust has something that will jive with like an async scheduler. But I did have a question, like how does it, once you have the schedule figured out, like how does that translate to actually telling the FPGA what to do? Like
Okay, so
this is
that's
something
the
I don't know enough about FPGAs clearly, but there's like some
mhm.
API, right? And how are you actually like calling that API to send over?
I wish there's no API. I wish there were. What's the API? The API is
There's a
Verilog
PCI Express bit stream that
yeah,
you're
yeah,
writing bits to.
yeah.
That's the API.
So here's how it works. Uh, you essentially struggling to remember the fancy name, but anyway, you take that schedule and you build a finite state automaton. You build an FSM, and the FSM says literally. So the FSM is not a smart FSM that does regex matching. It is an
Hmm.
FSM that says um, I have 1,000 steps in my FSM transitions. The transitions don't do anything except uh, light up wires. Those wires are the things that kick off your adder. So your FSM, which gets burned into your FPGA as logic,
Hmm.
right? So I have so there are a couple of different ways to encode an FSM, and one way to encode an FSM is I have a very like you can imagine like 1024 bits just packed in line, and whatever and different bit patterns which light up wires correspond to one stage, then the next stage, then the third stage, and the FSM just that's it. In transitioning from state 5 to state 6, it'll light up those 1024 bits in the correct pattern that then cascades down to all the adders lighting up. And so that's what, so you have the schedule, you extract from, it's called FSM extraction, which is actually not that hard. You're just like, well, I know what things are gonna when they're gonna turn on. Just connect them all up. It's a
Hmm.
simple kind of thing. It's like munging on the level of munging, and then you burn the FSM onto the into the bit stream. You burn the adders into the bit stream. You flash the bit stream, and then you hit go. Which is a dramatic simplification
Okay.
insofar, at least, as it doesn't talk at all about routing.
And I don't know exactly what you mean
Do
by
you hear me
routing,
still?
but
What so routing is kind of what it sounds like. It's TSP. It's basically, hey, I got a grid, I got a fabric of wires and LUTs, because the basic building blocks here are LUTs,
hmm.
literally. So that's why it's
Hmm.
funny as I've been. And there's wires connecting them that can be turned. There are switches, switch boxes, and you're like, well, I want this adder, I want this LUT to be a component of an adder. Okay, cool. I'm going to wire it up to all the LUTs and the BRAMs and the flip flops in the neighborhood. That's fine. That's not that hard. I mean, whatever. You might even be able to do it by hand. I don't know. But hey, this adder now needs to talk to the other one on the other side of the physical fabric of compute. And like, I can show you a picture. It's
So you're just
in
trying to like
my
co-locate the adders that depend on each other, close to each other in the
yeah.
FPGA.
That's definitely like an optimization goal. The more tightly you can pack these things that all play with each other,
Hmm.
the better um, critical delay. So there's this unit of interest called the critical delay. And if you're sending signals, the speed of light is real. It's not
Right.
infinite. And if you got like the adder that does one thing and talking to the adder that does the other thing on the opposite side of the FPGA, that's slower.
Hmm.
Your critical delay will be much longer than you would like for it to be. But this shit gets, you know, anything beyond the most trivial stuff will get insane. And so like Xilinx's tools have kind of okay routers. So the ILP solvers, they have an ILP solver for the scheduling component, and then SAT or ILP for the routing.
Hmm.
So in the tool is like well, there's some formulation of the routing problem. Looking for my paper. Okay, so look, if you scroll, so I'm gonna send you a link over here in a second. If you scroll down all the way to the bottom, yeah, Yeah. So what you're looking at is two different perspectives. Oh no, sorry. This is left is bad, right is good. Hotter colors means congestion. A bunch of cross wires, loop. I don't know, whatever. There's a congestion metric. It's actually I believe it's crossings. Hey, I got a wire that goes from point A to point B for some compute and it crosses another one, or path crossings, right? And there are literal switch boxes with like wires in them, and if you overburden the switch boxes, you fail to synthesize, place, and route. Okay, so the left hand side is failure to route. The word for this is fails to achieve routing closure. There's timing closure and routing closure. So the left hand side, super congested, everything's scattered. It's like one half of the adder is on one side of the thing and the other half of the adder is on the other side of the thing. And if you give it so you can give it a target for what is the megahertz that it operates at, right? And you're like, I want it to operate at 1,000 megahertz. Okay, cool. It says to you, it comes back to you and says, fuck you, you've placed your shit on opposite sides of the map. I cannot satisfy
Mm,
competing goals of
mm,
placing all this up. Okay. So the left one fails to route, the right one succeeds in routing. The colors, there's much less pink, much less purple. There's still congestion, but anyway, it gets much, much worse. So this was the final thing that I got to after a year of fiddling with stuff. It gets much, much hairier than this. Like ugly stuff. Anyway, yeah, so FSM extraction, if you just talk about scheduling, you're not talking about routing, but who cares?
okay. I feel like
No.
you kind of answered the question with the async dialect.
Yeah. Why Rust?
Oh yeah.
What is
Well, so okay,
the
so
library?
our well, this is like our MLIR project, right? Is like eventually we're gonna be lowering all of our like FHE stuff down through LLVM or scheduling directly on hardware. But for
Mm-hmm.
now, like doing that requires basically implementing the cryptography in the compiler. And there's a lot of details to get right in that cryptography, and there's a lot of
Sure.
decisions that you make about like which particular ways to implement the cryptography. And these things have already been done in lots of different libraries, and we
Sure.
know that it's going to take probably a few years to get something that really is good that goes all the way down to hardware just in the compiler. And so our idea is to have, I mean, I can show you we need a picture is really what we need. I think I do have a picture, but you'll see that we have these dialects. So OpenFHE is one of these popular crypto libraries, and TFHE Rust is another one. OpenFHE is C++, TFHE Rust is in Rust. And basically we're saying, okay, in the interim, for people who still want to use our compiler and get some of the high-level optimizations, we can just emit code in one of these available backends, right? And then you can compile it further, and then you'll have something that you can run. And so we can give like a universal front end to all these different backends. And then do like circuit optimization is something that we can do because the TFHE Rust backend doesn't actually optimize your program for you. It just implements the
Sure.
crypto primitives as quick as possible. Um, and so that's sort of what we're basically having like this layer of ways to get out of MLIR. And then people have like because right now all the people who are doing hardware acceleration have their hardware acceleration hooked in through some library. So they'll either hook into OpenFHE with their FPGA, or they'll hook into TFHE Rust with their FPGA or GPU or whatever. And then they'll basically say, okay, well, if you have code written against this library, I'll recompile it with my fork of that project, and then you'll get something that runs on the hardware accelerator. And so we want to get hardware accelerator numbers, and that's like the fastest path to do that. Um, so that's kind of the idea. Like why are we generating Rust code from MLIR? Why are we generating C++ from MLIR? That's the reason. Um,
You
yeah.
C++ for which one of the backends?
OpenFHE. That's the one I'm actually working on right now. And the CMake configuration has got me down because their CMake configuration is like very complicated. Like it does all like it like auto generates header files and stuff with like random things in it that I like can't. And like there's this thing like they use 128-bit integers, and like the
Um,
behavior of all of like the different C++ standard libraries on 128-bit integers is like not consistent. And so like I can't get random things to compile. Templates are behaving in it's a whole mess. But that's like not MLR related. That's just my job. Uh,
Isn't that
uh,
everybody's job to deal with this bullshit that's like the nooks and crannies?
to deal with the inconsistencies of the world. Yes.
Oh, well, I've had two things. Was it two things this week that I'm like, I cannot believe this is true and accurate? But like, I could tell you things about the project that I'm working at that'll blow your mind as far as absurd, like impedance mismatch or friction between whatever. Is my camera gone? Oh, I
Your
clicked the
camera's
camera
gone. It's
off.
been gone.
Oh man, I didn't do that intentionally. Yeah, TFHE has a C API. I googled that. I
Yeah,
googled C API for
there's
both
a
things.
different project called TFHE that has a like it's like a C++ or C project, but that one's I think not maintained
Talking
anymore.
about Zama. I'm talking about the Zama.
Oh, they have a C API for TFHE REST. Yeah, that's true. Um, but
Is that
we
not
are
preferable?
well, we're not using that because with Rust we get like parallelism and stuff.
Well, yeah, maybe, but I mean, yeah, I don't
I mean,
know.
it makes a big
Just
difference. Just being able to like multi-thread.
you can't. What do you mean? I mean, I don't know what that means exactly. Like they have utilities because I mean, like if you can call the C APIs, you should be able to do everything depending on what they've exposed. But this is a question of like, well, do they make everything available through the C API? Just
Well,
like
they
in
don't. The
MLIR, not
library
all the.
doesn't have any parallelism support, or at least it doesn't. The last time I checked.
Okay, sure,
And
sure,
so
sure,
like
sure.
I was saying, just use like regular Rust, like random Rust libraries like Rayon and whatever to handle
Oh yeah,
parallelism.
gotcha,
Yeah.
gotcha, gotcha, gotcha.
Um, yeah, and we've had good success with that in the past. It's just that we haven't integrated it into the MLIR side of the world yet. Uh,
Ugh.
yeah. So should we try the Python bindings? I think we can get it. I think we can get it
Oh
because
my
we
God.
fixed that
You're,
problem.
you're
And
staring at this window. You're staring at this window. It's like a siren song. Okay, let me go to the bathroom real
yeah,
quick, and then okay, you can give it a
yeah.
try. Yeah, but I reserve the right to sign off in like 30 minutes if it sucks.
That's fine.
Okay, here,
Only if it sucks. I'll make sure it
yeah.
doesn't.
Okay, let's do it. Okay. You still hear me,
So
right? I didn't turn off my
I can still
headphones.
hear. Yeah. All right. So I want to figure out. I think where we were last was like, what's the sort of minimal like hello world
Yeah.
Python program I can run that uses the upstream MLIR bindings. I don't know what happened to that. I think you sent me something and I have lost it.
What did I say? Remind me so
you
I
sent me
can.
like a hello world
Oh, like an
what
actual
was it?
Python program? You
Yeah,
want
like
like
a
an
Python
example?
program that like uses the upstream bindings to like do something. I forget.
I mean, I got tons. I can whip one out in 2 seconds if you manage to get this to actually work.
Let's say
I mean, there's a bunch of tests. So the easiest way, if you don't want to get fancy, is grab one of the tests. Okay, so let me find the right one. What's your favorite dialect?
am I like is this like a test like how basic of a
No,
bitch are you if you say your favorite dialect is math?
no.
Like,
No, I don't.
yeah.
No. That's nothing like that.
Oh yeah, my
Here.
favorite dialect is a riff. It's index.
Okay, so send you a link with highlights and everything. So that snippet, those 40 some odd lines, if you manage to see, if you so I don't know what you just did, right? Like this is done, but I don't know what you just did
Yeah, that just built the
because
upstream Python bindings
yeah,
target.
well, you built the core. I don't know what that is. Where are the artifacts that it built, so I can at least see. So there's an SO. Okay,
Yeah.
cool. So there's an SO and there's an archive. That's impossible, but
I mean, I think that's just how Bazel does it. But so like if I want to like depend on this, right? This is just MLIR dialects, so I should, I think, just be able to like say like deps equals and then pass in that, right?
and what does that give you in the
Uh,
Python and for the Python interpreter? What
yeah,
can
so
you import?
that would give you yeah, well it would give you the access to all of the Python files exported by that
To
binding.
those two, which are those two files?
Yeah. I mean, so yeah, so I mean, well, okay, I think the fastest way is just to try it.
It's
So
not
I'm
without a doubt, it's not gonna work. Before you do that, can you get can you do just tell me what the size of the SO is?
Sure. 29 megs? Is that roughly right?
No.
No.
It might be right. Let me see. Sorry, a second. Let's see. So let's see. I got underscore MLIR. Yeah, okay. So that's the okay, I buy that. What you're looking at there is but it's misnamed. It's named wrong. So Python is gonna prevent you from using that because the way that C extensions work in Python. Is this true? Like
Well, so in theory, this is using
okay,
that
so
like PyBind 11 nonsense, right? And
yeah. But the
so
way but PyBind 11 doesn't do very much on top of what I'm about to say, which is the name has to be the same as a define. So there's a hash define that Python uses. Blah blah blah. Okay, what is that? What are you trying to do?
does not have mandatory providers PyInfo.
What did you just try to do? Oh, you
So
that's
I tried
your
to
thing.
build the because I just pasted this in, put in the dependency, and tried to build it, and it basically says that like this thing does not give you any Python stuff. It does not
Yeah,
have
it's just
mandatory
a yeah
features
yeah
PyInfo.
yeah.
But so in theory, okay, but if we look, let me pull up the upstream.
But if you want to just try it, like I can tell you how to try to import it. Just like forget Bazel for a second and building that target for Bazel. or through
What do you mean?
Bazel. No, I just
think-
want to test if the thing. I just want to test if that SO does what I think it does.
Okay. And how would we do that?
So go back to the editor.
Oh, sorry.
Yeah. Okay. Wherever the path. Okay. Scroll up in the terminal so I can just see right in front of my face the path to the artifact. Yeah. Okay. So you see that Bazel bin.
Yep. This SO.
Yeah. What you want to do is, this is not going to work because these things are supposed to be named in a particular way, I believe. Actually, well, whatever is easier. But so I'm going to send you the thing in chat. What you want to do is you want to add Bazel bin external LVM project /MLIR to your Python path. Bazel bin /external /LVM project /MLIR to your Python path, and then start Python. So copy paste that thing just in case I fat fingered it. But you want essentially the directory where that SO lives. Yeah. Now try import the name of the SO without the SO suffix.
Undefined symbol.
Hey, that's not bad. That means yeah. So it linked wrong. I don't know what that thing is. That's something in LLVM, right? Hashing something. But so the build process messed something up. But it did try to import it, which is fine. It's good.
Well, so okay, so
you can do LDD on that thing. So if you drop it, you exit the interpreter
LD?
and then get the whole LDD.
LDD.
Yeah, the whole path. Yeah. It'll tell you what it's missing. It's not what I expected. It doesn't have any runtime dependencies. It just failed. That's very strange. That, as far as I understand, so there's an undefined symbol, right? So that means like there's a function that it needs. It finished compiling that shared object finished compiling without this function in the shared object. That's what undefined symbol means. Usually, for all times I've done this, that means there's a runtime dependency on another shared object, right? But none of these shared objects that are listed in LDD, which is what this says, what are the load time dependencies or runtime dependencies, are LLVM. They're just like GCC. They're like standard lib shit. So I don't understand how that thing compiled, because either you have a runtime dependency that is then
it's just compiling as a library. It's not trying to link anything. So if I tried to compile this into an executable, it would fail at link time.
No. Sorry. For a shared, again, I'm speaking from like, in all the other times I've ever run into this, a shared object will fail to compile unless you say, hey, there's an external dependency. That, like, you need a header. You need an extern not an extern necessarily declaration, but you need a header that says it's okay. So you have a header compiled with the header.
I mean, I think that's an existing dependency upstream, right? Like if I pull up the upstream situation, right? This is the thing that I compiled and depended on. This is MLIR Python bindings core, and here it has a dependency on a target called MLIR bindings Python headers.
So when you're missing is LLVM support. What does that // mean?
That just means from the root of the project first, this is like in the current package, if it's just a colon. / means like absolute path. And so this is like MLIR support. This is LLVM support.
Yeah. So that hash function is in that target. That's a target, right?
Mm-hmm.
That
LLVM.
so LLVM, none of the other one. LLVM support. That hash, without a doubt, that hash function is an LLVM support.
Okay. So
and that's supposed to be statically linked in.
Okay.
In CMake, the LLVM support library is statically linked in. Like if I go to
Yeah, I feel like I want to know like how does TensorFlow handle this, right? Because we did this whole thing where like we figured out that TensorFlow is the only one that actually knows how to configure this in an out of tree project. And they are setting up, what is this link you sent me?
So that link is kind of like a sanity check or proof of what I'm saying. These are whatever. These are the bindings to whatever my dialect. That module name is that module name _AIE is the same exact. That name is going to be lib MLIR Python bindings core. So your thing got named lib MLIR Python bindings core. My corresponding thing is literally named _AIE.so. So they're the same thing. And the LLVM support library is statically linked in.
Okay, so how are they actually getting PyBind here if they don't depend on this? MLIR bindings. Are you kidding me?
How is Jax doing?
That's a good question. MLIR bindings. What was it called? MLIR. Okay, let's try file build MLIR. Path build MLIR.
Expand out, show 9 more matches. Okay, fine, got it.
I'm looking for these like MLIR. They're all called MLIR bindings, right?
Yeah. Can you let's go. Keep going. No, keep going. Okay. Because it's not case sensitive, but they're somewhere here, right? Mm-hmm. Try Mosaic. Mosaic is the one.
Mosaic is their like custom TPU dialect. But looks like this is all in CC. TPU dialect C API headers.
But, yeah. Without a doubt, because I was poking through there last week, and they use the bare naked upstream bindings for arith and stuff like this.
You're saying instead of the Python API?
No. Sorry, I'm saying they're using the Python API. I'm saying that they're not skipping the API by some magic trick. That they are, in fact, they must be using. And for a penny and for a pound, I'm pulling up LLVM.
Okay, here we go. TPU dialect PyLibrary. JaxLib, MLIR libs, TPU.
That's yeah.
Is this it?
No, that's for their dialect. That's a C extension that you can add. Get my little things struggling. Yeah, you can define
Oh,
one of
here we go.
those for
Python
each
bindings
dialect.
for MLIR TPU dialect, right? Is this not it?
Yeah, but that's a dialect at a time. And yeah, that's important for you that eventually wants to have a corresponding thing for like your dialect, but those aren't the upstream. So like, look at it. Look at that. Look at line 14 or whatever, or 24. JaxLib MLIR underscore MLI libs underscore TPU extension. This is for their extension. This is a
Right.
C extension for their extension. You're looking
Okay.
for something that gives you the.
So
I'm
like,
for
is this
sure they're
not
using the
this?
upstream.
Is this not MLIR dialects ODS
Is that
comment?
no, so that's that underscore C extension is exactly what we're looking for. Where is that built? You're not going to find that string anywhere. That string is upstream. So, but that is in fact exactly what I'm talking about. Hey, the fact that they use this thing means they are building what you built just now locally. The
Right. And
question
so
is
if
how.
I'm not going to find this string upstream, I'm going to find it in whatever is the build dependency for this particular, whatever is building this file, right? Because that is what's going to point me to MLIR dialects ODS common. In Bazel, you have to explicitly declare all your dependencies, right? So,
If you're going to look for, so that's a rename. That's a rename. If you're going to look for something, look for underscore MLIR.
this is a
Just
rename.
underscore MLIR. That it's underscore CX is a rename of underscore MLIR. So the actual schlib is underscore MLIR dot SO. And this ODS common is a Python file that renames it to underscore C extension. So if the thing that you're saying
But what I'm saying is that this thing, like whatever is providing this MLIR import, is going to be defined in whatever thing is using TPU Pi as its sources, right? So the dependency has to come through one of these two things. This is probably the custom extension, and then this is probably what has the Python bindings in it. So we're looking for JaxLib MLIR. Where is it? Is what? Oh, JaxLib MLIR. Dependencies. MLIR lib. Oh, it's another directory, yeah.
It's underscore under, yeah, it's there. It's on line 53.
Okay, so here, Pi extension, and here's the situation, right? So we need this in my project.
Yeah.
Because this is not doing any of the custom stuff.
This is doing something weird though. This is different than what you built because you see how it says no core no C API.
Mm-hmm.
Yeah, I don't know. What they're doing here is, hey, that main module CPP, that's an upstream file.
Yep.
That's literally it's like, I mean, they're not building the target. Yeah, I don't know. Okay, do that.
Yeah, I mean, like, okay, but so like, I want
to look at the name. Look at the name too. Look at the name on that Pi extension. 47.
Yeah. You said the underscore.
Yeah.
JaxLib MLIR CAPI shared library. I mean, I can leave that out, right? Because this is that. I'm just looking at they have like really weird link ups here. Like, okay, Mac OS and Windows. Okay, I can ignore those, and then the default is this. But I don't know what this thing is. Like,
you're yeah. So I know what that is.
Okay.
You're changing the run path, R path of this. I guess all the schlibs in that are built by the script to be right there where they're sitting, instead of looking at user/lib or something. They're going to look for the runtime dependency. So there's a thing that you said that isn't true, that I need to point out. JaxLib MLIR CAPI shared library, you do need that, or you need your own thing. You need your own version of that. Yeah.
See what this is.
I don't know why they do it like this, because you see what they're saying. They're saying, I want to build main module CPP and link it against the no CAPI target, but I want to use my own because I want to use my own CAPI.
Oh.
Slib. They're not. You need the bundle of CAPIs that main module depends on. Main module.cpp depends on a gang of CAPI, all of MLIR CAPIs.
Do you think if I just instead of doing the no CPI, I just did the regular CAPI, like take out the no here, then
I believe
I wouldn't need this? Okay, let's try it.
so. But the weird thing is, try that. It's weird to me because
Oh, and then they have their own custom Pi extension. No. This is the worst. Okay. Here we go. Jaxlib. Jax.bazel. Pi extension is just a PyBind extension.
here, fuck that. Do this. Do this. 1 second. Here. So the correct target in upstream is this one.
Oh. Ah, okay.
Yeah. And there you go. This solves my conundrum. Link shared equals 1, link stat equals 0. So that .a archive, I was like, I've never seen a .a archive for that. That's wrong. But there you go.
But so I can just depend directly on this then. I don't need to make my own nonsense.
Yeah, I guess. Yeah.
And then so this is wait, sorry, I'm confused.
Is it underscore MLIR.so?
And then I don't need any of this stuff anymore. Have mandatory providers Pi info. I think I still need a Pi extension, don't I?
Well, I don't know how Pi binary has to have through and through Python infos. That's
well, no,
interesting.
I'm basically just trying to take this thing, this program, and run it as like a main.
No, I know, I get it. What I'm saying is, what this error is saying is, MLIRS doesn't have a Pi info attribute.
Yeah, well, so it doesn't basically when you create this as a dependency, it runs that CC binary rule, and then and if you give it as a dependency to a Python target, it'll be like, oh, I expected that dependency to provide some information about what it gives to a Python target. So I think the Pi extension.
You don't want Pi extension because Pi extension, I believe, will try to compile something. That's the problem. You don't want to recompile things.
Okay, well let's search for this MLIR.so source forge or source graph.
Yeah. Can you not? You showed me how to do this at the command line, but I wasn't paying attention. Can you just build that target and poke the artifact?
Build this? Oh, build the MLIR.so.
Yeah. Yeah.
Yeah. Yeah, so that build's fine. And if it's a CC binary, I can't run it, right? I don't think so.
No, but you can load it. You can load it. You can load it the same way
that
the same we did just now. Yeah, exactly. Yeah. Import underscore MLIR.
Wow.
There you go. Okay, so yeah, there you go. Those are all the those are exported PyBind. Yeah. So now you can do stuff. Honestly, if you were willing to copy paste C source, Python source. So all these things that like those MLIR.dialect stuff, that's all Python.
Ah, okay.
So you need to import what, like, I don't know what
So
the
then
thing is, but
what Python library is providing these?
yeah, I mean there's some Bazel thingamajig, right?
Well, there's like a source file upstream, right, that has them.
That's correct. Yeah, I can tell you. Yeah.
Yeah.
So like,
What's that source file called? Or one of them?
func.py or rith.py.
Arif.py.
Each of those is the from MLIR dialects is called like memref.py. Yeah, here you go. So these are over here. Let me show you. Pull it up. Here, check this out. There's just file group, whatever a file group means. I don't know what that means.
That just means you group them together into one target to refer to all those functions. Func.py files, func.py gen. And so there's one of these for each dialect. It looks like it.
Yeah, there's two. There are more than one. But.
Interesting. Okay. So now where func.py files? So that one is actually okay. Jack's MLR build. Symlink inputs, func dialect.
Yeah, I don't know why they do that.
Like here, okay, look at this. This Py library. Oh, right.
Yeah.
Symlink inputs. I've never seen symlink inputs in.
Yeah. Yeah. I don't. Who else does this? I don't know. I saw this somewhere else, but just grab all those, except for the stable HLO and MHLO.
Symlink inputs is also a custom Jax thing. That's why I've never seen it before. I mean, what I'm wondering is like, why is this not upstream, right? Like, why is there no like Py library definition that just like gives you all of the standard? I mean, it's because you haven't done it, right? Is that the short answer?
Yeah.
Yeah. Okay.
Yeah. I mean, me or like one of the two other. I mean, so you know who Stella is or Alex?
Yeah. Alex Zanenko?
Yeah.
Yeah.
Or Jacques. Yeah. So yeah, because I don't do Bazel, so I've never put time into this.
Okay. So then the inputs. Okay, interesting. I feel like close to figuring this out. I guess symlink inputs is probably allowing you to like treat the files in some upstream repo like they're in your own repo.
Make some sort of sense because those files are in LLVM source. Those are not generated or compiled or anything. So
yeah, wraps a rule and symlinks input files into the current directory tree. It's like a really weird way to do it, but like another like custom rule.
it's in the same. It's in the symlink files Bazel.
Yeah. It's yeah, this is a weird way to do it. I mean, like, I feel like what I would do is I would just like define an upstream Py library that bundles together all the different files that you need, and then out of tree projects can just depend on that Py library.
So the deal is
do a Python target.
What this emulates is if you do LLVM dev in, like, I'm just working on LLVM itself and I'm working on the Python bindings, what happens is you have a build directory. In CMake, you have a build directory, right?
Mm-hmm.
And the built versions of these Python files are in fact symlinked to the source files in the build tree, right? Like, and that makes sense. And that makes sense because while I'm iterating on some Python component. What's the point of recompiling, reinstalling? Just symlink to what I'm editing already. So this might be like, but of course, like when you distribute, like, oh, I'm gonna do LLVM make and CMake install, it's not gonna symlink anything. It's gonna copy the files. So this looks to me like, well, I only use this when I'm doing, but it's not. I mean, I don't know, right? But it's like
Maybe it makes sense in the sense that like they are going to be distributing this code, right? Like I'm looking at the commit that authored this thing, and it's like use symlink files to add version pi jaxlib rather than copying as per the wheel assembly process. Like it seems like there's some like distribution situation going on.
maybe. The other thing that I was thinking was when you do LLVM project is a dependency, it's not going to do LLVM CMake install equivalent.
Nope.
It's going to build. Yeah, so
separate.
that's so that makes sense because you're never going to you're not when LLVM is a dependency of whatever like HEIR, right? What you're doing is you're building the build tree. You're ending up with the build tree for LLVM.
Mm-hmm.
And so, well, why would I copy LLVM build tree source files? Just, it's a build tree. It's not a distro. Anyway, I don't know. That's just the thought process. But like, okay, if you want to get started, though, I can tell you how to, like, what do you want to do? You want to copy some rules, or you want to generate some IR?
I'm not sure. Well, I mean,
in fact,
because we can't run this, right? Because we don't have the actual dialects.
Well, the funny thing is, I can tell you, I can show you how to run this.
Okay.
You want to know how?
Add an underscore in front of all these things?
No. 1 second. I'll tell you. Okay, so I'm assuming. No, don't change anything. You don't need to change it. I'm just assuming that this Python bindings. So this is not gonna. Okay, I'll just show you what I'm talking about. Pip install MLIR Python. There, do that. Yeah, there's a tick. There's a back tick.
Yeah,
right?
I saw it. Sorry.
Cool. Now, assuming that these two interpreters are the same, you can just run that thing. Yeah, you can import MLIR. Yeah, sure. Yeah, there you go.
Wow.
So, is this thing configured to recognize the Venn? Because then you can get tab completion for all this stuff.
To recognize what?
You have a Venn activated, a virtual environment, right?
Yeah.
So I don't know if you configured VS Code to yeah, okay, so I can see at the bottom right. So you should get tab completion for all these like things, most of these things, like memref whatever and index type whatever and blah blah. Control space? I don't know.
Lightning fast.
Yeah, I don't know. How about just affine dot, and then control space? Yeah, I don't know. You got me.
That's fine.
There's there are type stubs for everything.
Okay.
Yeah. Okay, so I don't. So this is unfulfilling, right? Because you didn't actually install it.
Yeah, I mean, I think I'll probably spend some time offline tinkering with it to get something to work. Uh, uh, yeah, and then I guess the next part would be like making our own Python bindings for our own dialects. Um, but
What do you have so far in the build? Let me see your build, Basil. You don't have nothing. You just have but yeah, I don't know. Let me see what you got.
right, I mean,
Just that.
I just am trying to run this with the right dependency here. Uh,
Yeah, my bad, man. Like I owe you an apology for not doing my homework because even though I
well,
said that I would, I've been buried under
does
like
yeah, that's fine.
does what you were gonna say.
I don't remember.
Does does I don't know. Does something.
Yeah, I think okay. I think I'll figure this out another time. Because this is
Yeah. Is it
somehow
in?
Basil is like becoming my specialty.
I'm not a huge the fuck is the guy's name? The Y Combinator guy? The
All Graham?
guru. Yeah, Paul Graham, the soothsayer of our generation. I don't really give a shit at all,
Don't
but
say
he
that.
has he's to a certain group of people he is. I don't know. He has one thing that I agree with. You're like, oh, I'm becoming a Basil expert. I'm like, there's money in that. He says, where there's muck, there's gold.
Mm.
Which is like how I've approached my career. It's like I could have stayed in PyTorch land, but I went all the way down into the dirty, ugly details of like assembly that nobody wants to touch because like, so like I hate Basil. I would pay you for this. I would pay you for this service.
Yeah, I
Okay,
feel
cool,
like
man.
the annoying thing with all build systems is when anything becomes custom. Like any kind of custom stuff you add to your like it's like all the JAX custom rules, all the TensorFlow custom rules. It's just like the more custom stuff you add on top of the build system, the worse it is, in my opinion. And I've seen
Let
that
me ask
true
you.
of CMake as well.
Yeah, and CMake is horrible. I mean, like CMake is I'm not a fan at all. Like CMake is the weirdest programming language thing. I don't even know, but like I am under the impression that every single thing in there is a macro. There are no functions. There are no values. Everything is a string. It's really dumb. I don't like love CMake at all. I just that's the evil that I know. But I have a question. So like when you're in Google land at your day job, does this thing, which I think is called Starlark, right? This is the language.
Mm-hmm.
You have full IntelliSense and all this stuff in your editor.
Yeah. Yeah. I mean, it's
Okay,
like
and
all Google code's checked in, so not only is it like yeah full IntelliSense, but it's got uh what do you call it? Like I mean, yeah, you can like jump to the source of everything, but it's also like it's like treated like a first class language. I mean, here it's got syntax highlighting, but I don't know if it's got like linters and all that stuff too.
yeah, so this is the thing. You said exactly the right words to like satisfy my curiosity. Is it in fact treated like a first class language? You know
I
what
mean,
I
it is
noticed?
because it's
What
it's outside. So there's build files, which are like a really limited version of Starlark, and then there's Bazel files. And Bazel files are like you can write any Starlark code, and Starlark is like just a restricted subset of Python. Like that. So you can do like list comprehensions. You can do like loops and like arbitrary function calls and stuff. And then they add this whole like rule mechanism where you define a rule and you define the implementation of the rule as like a layer on top of that. But if you just want to write like random Python code, they've only got like you don't get like iter tools or whatever. They have some like
hmm.
some helper functions to help you out, but it's like it's basically just Python.
Yeah, so that would make it way bearable and way preferable to CMake. Sometimes I'm like, I have no idea what's going on. I'm just like, in CMake you have message fatal error,
Hmm.
like message fatal error string. That's how I debug. That's my printf debug in CMake. Just fatal error and print the whatever I got going there.
Yeah, in some sense, Bazel's are Bazel and Starlark are nice. But then I do think that, yeah, like there's too many layers of indirection, as with any complicated thing.
Yeah.
But like I think do I have like okay, so like importing LLVM, right? Like, okay, if I want to like make my own function, I can just like define it like Python code. I can like define strings, and then this is calling a rule that somebody else defined with like, like even like false is like Python syntax. Like they make it very, very close to Python. Where I have some more. Yeah, like if not data, data is empty string, append two lists together. And then I have like, I wrote this wrapper around like lit testing so that I can like make it easier to just like run all the lit tests in one directory.
Oh, bro, that's so funny. Sorry, I was just looking at this today. Whatever this thing is, it discovers lit test. Well, but sorry, there's an upstream something for lit test.
Yeah, I mean, there's an upstream. It's weird because there's an upstream something, and then Google has their own like custom internal thing to work with like Google's weird testing infrastructure. But yeah, it's basically the same. Where it's like you have a PyTest that actually runs LLVM lit and passes in like the right arguments and stuff, and then you can just like glob for all of the things that look like MLIR, and then for each one you create a new lit test for that.
It's so fun. I was like, because I want whatever. Like I want to run lit tests independently of CMake, independent of the lit test suite targets in CMake.
Yeah,
because that's how it works in LLVM.
This one's nice because so if you oops. Yeah, so each basically, let me do, so each test target is its own independently runnable thing. And so then there's a file group that gives you like all the files that Bazel needs to run the test, and then there's the test target itself. And so if I just want to run a single lit test by itself, independent of any other one, I can do that. And the macro does that because in this loop, it's calling lit test, and lit test when you call, or lit test is itself a function that calls PyTest. But anytime you call PyTest, it creates a new node in this graph, in this like dependency graph of targets, and then it gives it the name. And I said just add .test to the end of the name, and then you can run like an individual.
I have a question.
Okay, and then I can compile.
You know how lit tests, when you specify them in LLVM, sometimes the config, the .cfg, there's like build time string interpolation, right? Like there's two parts to the CFG.
Yeah. You're saying this like weird Python file that's like got like a magic config object that comes from nowhere, and yeah. So I had to spend a while basically setting this up so that Bazel could know like how to like configure lit properly.
What? Okay, that's useful. It'll be useful in if I try to do something. My question to you is, do you not have build time settings? So like in this I work on this hardware compiler thing, right? And there's a whole bunch of like build time strings that are like, well, where's the proprietary target code gen compiler, right? So there's like two levels to this compiler. There's the MLIR compiler, and then there's a target specific code gen for the architecture. And wherever you build, hey man, that target specific code gen compiler could be somewhere else. And so you got to find in the file system. So that's a build time configuration.
No. Right, yeah. So what you have here is in any kind of target, there's like a data rule, and you can pass that basically the location of any targets that correspond to tools that you want to run. That's if you're working with so I mean in this case it's defined as like a Bazel it's in that same workspace, right? You have a target, it refers to that target, and it makes that binary available in some particular path. and then you can just like run that.
So that's for Bazel. What about lit? Like,
Yeah,
I want. Sorry, go ahead.
Oh yeah, you're saying like how does lit have access to these tools?
No, how did you solve that same problem? Because the thing that having a lit CFG .py in your build directory, which is what CMake does now, right? There's a string parameterized template in LLVM that fills in like the location of blah blah blah, the architecture you're compiling for, Arch64 x86, and that file is dumped into your build directory, which means that I have to run CMake. I can't just run lit on my directory. That's the thing that I have trouble with. You have a bunch of lit.cfgs or run.lits or whatever, right? Like right now in your
So you're
test
talking about
directory.
this thing here, where it's like,
Yeah, something like this. This gets quote unquote reapplied as a lit.cft.py, but in your build directory. You know what I'm talking about?
I mean, not really. Like, I don't know how it works in LLVM specifically, but like LLVM provides this LLVM configure Bazel rule that you give it, like, it has some options and you
Yeah.
set those options for, I think specifically for those like build time constants, like which architectures are you building for?
Can I
don't know
can I
how,
share screen?
yeah, sure. I don't think that ends up affecting lit though, is the thing.
Yeah, so it might be the case that you've never used this dimension of lit, which is what I was wondering about. Okay, so what you're looking at is, like, forget this left window that I'm going to make as small as possible. In my build directory, I have a test directory for that set of targets, right? So down here at the bottom, I got all our tests and stuff, right? Or sorry, that's LLVM. Fuck it, that's LLVM, right? Under MLIR, you got all the tests, right? And these have somewhere in there a CFG, like a lit CFG, right? I'm going to struggle to find it. But per directory, you can specify a lit local CFG, right? Yeah, right there, right? You can see my screen, or you can. No, you can't see.
Well, yeah, I know there's like a local lit CFG that's specific to each directory.
Yes, I'm just like, okay, like here, right? Inside Python, there's a lit local CFG, right? And then at the root of the test directory is this thing, lit.cfg.py, right?
Mm-hmm.
Which has all this kind of stuff that you were like, where does the config object come from? The config object for me comes from here. These things are all filled in at build configuration time. Like you can see my triple, you can see whatever, the path to the source root, all this kind of stuff. This starts life as lit.site, as a .in file.
.site, yeah. I know what file you're talking about.
Yeah, there you go, right? These build time configuration strings that CMake fills in. And this is the thing I'm like, oh, how did you solve this problem? Because I need a build tool to like make this not a template, but to make this a Python file. Because it's a template right now with template parameters. And if I have this, well, I can run the lit Python, like pip install lit, and if you have this, it's fine. But your build tool is the one that fills in these values. And I was like, how did you do that?
I don't even have one of those.
Yeah, that's what I was thinking.
This is what's weird about, because I remember thinking about this like in detail, right? We have the lit config py, but we don't have the templated in file.
Yeah.
But like we're still building, like there's a lit, where is it? Oh, maybe it's, let's see. Yeah, so I mean I'm just building the lit from source.
Yeah,
and then not passing in any sort of special config.
Yeah. I mean, it's good. I mean, so that's the main blocker for me to skip CMake for lit tests, because I want to skip the thing that I started saying was like, I would like to skip CMake for lit tests. But I can't, because CMake is the thing that fills in all of those template parameters. Which I could do by hand. But I was like, oh, I wonder if you figure out how to do that too. Anyway, not your problem, because you don't have any of those.
Let's go.
Okay, I'm gonna make a solemn promise to try to do this by myself as well this week sometime. I have some bandwidth for this now. So then next time we can actually have a hello world at least, and maybe next time we can graduate to stuff for your dialects.
Yeah. Somehow the window disappeared. Anyway, yeah, I think that'd be nice. I think I'll try and get like a Bazel native build thing showing up, so I can actually get the thing running without like pip installing a wheel or anything like that.
Yeah. Sure, of course.
Yeah.
Cool, man.
All right. Well, this is fun. I'm not sure if there's much value to streaming it, but it's always good
Not yet.
talking to you.
Yeah, same. See